And this one, let's explore the concept of a hole in a graph. So this is a video for those who want to understand how to find them, but also to understand a little more deeply why they occur. I think that's just as important. So I'm using a website called Desmos.com, and then you type desmos.com/calculator. Brings you to this nice page. And I'm going to type it in here as follows. F of x, for example, here equals x divided by x. That's very simple. And here's the graph. Let's zoom in on the graph, and so you can see what the problem is. Okay, so the graph is the red line. Now click on the graph and move the point across the graph. Look, remember, this is the graph of x over x. So you see, for example, like when it's negative 0.206, that's the value of x. When that goes in the function, 1 comes out. Remember, the x-coordinate is the input, the y-coordinate is the output. All right, go over, you see, for example, when negative 0.139 goes in, 1 comes out. But what happens at 0 itself? Look carefully. There's a hole. Do you see it? It says 0, comma, undefined. So here, when x goes in, you end up with an undefined value for the y-coordinate. The reason is that the function is x over x. That's like 0 divided by 0 when x has the value 0. Let me zoom in here so we can see things a little better. It gets kind of interesting. So now, see, it's right there. There's a hole. So 0, comma, undefined. Let's change things up a little bit. What if I want a hole, for example, at this value of 1? Right now, look on the graph. It says 1, comma, 1. That tells you when 1 goes in, 1 comes out. What if I want a hole at that value? That's a good way to understand them, to be able to actually just build them. So here in the graph, take a look. And the function on the left side, next to x in the top, type x minus 1. And that's not enough because that completely changes the shape of the graph. So in the bottom also type x minus 1. And we're back to a horizontal line. So this function now is still that same red horizontal line, but it's not the same function anymore. And the reason is this, take a look. Move a point across. So you see, remember what this means. This means when half goes into the function, 1 comes out. This means when 0.63 goes into the function, 1 comes out. This means when 0.8 goes into the function, 1 comes out. Except now take a look. When you approach from the left here, look what happens at that value itself. Look, 1, comma, undefined. Now look, the value of 1 from the x-axis gives an output from the function that is undefined. That is what that means. So look at the left side of the function. Right here, you see where it says x minus 1, but the hole, the x-coordinate of the hole is at positive 1. Do you see that? So that occurs at the opposite of the values that you see. So since here in the function you see x minus 1, the hole is at the opposite of that value, which is positive 1. So it's the x-coordinate of the hole that occurs at positive 1. But the hole itself is on the graph, okay, and not on the x-axis. That's important to understand. Take a look. Imagine now you want a hole, for example, at positive 2. You can probably figure this out. How would you introduce a hole into the graph at positive 2? So pause the video and look at the expression and modify it. It's very similar to what I've done already. Alright, I hope you've done that. So again, the goal is to get a hole at positive 2, so you type a factor of x minus 2 in the top and a factor of x minus 2 in the bottom. And now, let's do this. I'll zoom out a tiny amount on the graph. Again, when you move your cursor, you see right here, still at x equals 0, there's the hole. At positive 1, there's still the hole. And now scroll over to here, and you see there's still a hole. Right there, you see 2, comma, undefined. So these factors like x minus 2 and x minus 2, x minus 1 and x minus 1, x and x, the factors between the tops and bottoms, if you think about it very carefully, the x and the x would cancel off, right? The x minus 1 and the x minus 1 would cancel off because 1 is in the top, 1 is in the bottom. The x minus 2 and the x minus 2 would also cancel off because 1 is in the top, 1 is in the bottom. And if you do that, you would end up with literally f of x equals 1. But it's not the same function as this one because the constant function 1 has no holes in it. This function has 3 holes in it. 1, 2, and 3. So they're not the same functions. If you simply take these and reduce the fraction so that gives you just 1, It's not the same function anymore. Keep that in mind. Let's do this one last time. Imagine this time the following. So if you want a whole lot positive 1, you have to have a factor of x minus 1 top and bottom. If you want a whole lot positive 2, you have to have a factor of x minus 2 top and bottom. And the question is, what if you want a whole lot negative 1? What new factors should you have to introduce into the top and the bottom? Again, what if you want a whole lot negative 1? Pause the video and then think about it a little bit. So here, take a look. In the bottom, I always put the opposite. So I'm going to put here x plus 1. Same thing in the top. The factors have to repeat between the top and the bottom or it's not a whole. So x plus 1. And now, take a look. I'm going to move my cursor across the red line and look, right here. At negative 1, you see, there's now a hole. It's undefined, in other words. It's a bit tricky to position sometimes, but I think you get the idea by now. So when you look at it, this graph has now, think about it. 1, it's a bit hard to get sometimes the position. 2, 3, and 4 holes. That clearly would not be the same as if you just reduced all the fraction here and then you end up with just this. Take a look. G of x equals 1. That's true that you can do that. The x and x will cancel. X minus 1 cancel, x minus 2 cancel, x plus 1 cancel. That is all true. But then you get this constant function x equals 1, which right here is in blue. And the only problem is, look, when you put your mouse on the blue constant function 1, at negative 1 itself, it's defined to be 1. At 0, it's defined to be 1. At positive 1, it's perfectly defined to be also 1. So these functions, f of x and g of x, you have to be really careful, are not the same. They're the same over many different points, but at some key points, like x equals, for example, where x has the value 0, 1, 2, and negative 1, the functions f and g do not agree, because f is not defined and then g is, so that's important to understand. Thanks so much. I hope it's been helpful. I'll see you in another video.